Okay, the uh, the last thing that I wanted to look for is three of a kind. All right, so we're going to write a method called is three of a kind. Now, the challenge with this one is, well, I think we could use a pattern that's similar to is two pair, but this is getting kind of tedious, I think, because we're going to have to write a for loop inside a for loop inside another for loop. So we'll start to do that. Well, maybe we'll write it and then I'll talk about maybe a better way. Okay. All right. So we're going to have get hand sub I equal to get rank of hand sub I equal to get rank of hand sub j, but that has to be equal to get rank of hand sub k. And I is not equal to j, and j, well, and j is not equal to k. Well, that won't be the case anyway, but actually it could be. So we just have to make sure that I isn't equal to j, and j is not equal to k, and I is not equal to k either. So basically, none of the values are equal to each other. So I isn't j isn't k, I isn't k, j isn't I. All right, so we're making sure that none of that is true. Okay, so we also have to add another for loop here. Int k equals 0, k is less than hand dot length, k plus plus. We'll indent. I'm always careful to make sure I've got these indents correct. Even though it seems like it's faster to write code and not do the indenting, it just makes it clear where things are being processed. Okay, so just to explain what we're doing here with is three of a kind. So in order to have three of a kind, what we need to have is I, the outer loop, is held in place. So we're fixing I. We have a j from the middle loop, so, and j is a different value than I. And we also have a k, and k is a different value than I and j. Okay, if we've got three with the same rank, given those conditions, that means we have three different cards, three different positions in the hand, three different ranks, but they're all the same value, then we're going to return true here. We don't need a pair count because we're never going to have more than one three of a kind in a hand of 5 cards. We'll return true. All right. And here, if we get out of this, we'll return false. Okay. So in theory, this should work. So I hope it makes sense. It's the same pattern as is one pair and is two pair. It's just we're looking for a single situation where we have different values of I, j, and k, and the ranks for the hand locations for different values of I, j, and k in the hand are the same. All right. So I think it's a little harder to get three of a kind, but let's see if we can get it. Just got to do a little tweak here. Oh, and get rank and sub I equals, there we go. Just a little mess up there. So I had a sort of chain of equals, which doesn't make a ton of sense, but this should make more sense. So get rank hand sub I equals get rank hand sub j, get rank hand sub I is also equal to get rank hand sub k. All right, and we're saying that I is not equal to j is not equal to k, and I is not equal to k. So we're just making sure that the I, j, and k are all different. All right, so let's compile and run that. All right, we got nothing on that hand. Oof, got a lot of junky hands here. Got one pair. Now, I might want to just run this for a little bit until we get a hand that is three of a kind. Doing this manually might take a while. So what I'm going to do instead is, oh, there we go. We got three of a kind. Let's see. Yep, a two of hearts, a two of clubs, and a two of diamonds. And that gave us three of a kind. Excellent. Well, it would be tempting to just leave this alone and say that we're done. But I think one of the things that computer scientists do is they're constantly trying to think of, can I do better? Can I make this code easier to understand? And I think we can do an improvement here. One strategy to rewrite this three of a kind would be to do something like this. I'm going to create a rank array. And it's going to have 15 values in it. So the rank array is going to be responsible, maybe we could call it the rank count array. It's going to keep track of the count of the number of times that I find a card of a particular rank. That's what the job of the rank count array is. All right. So if I find a card, like let's say, well, let me just show you what it might look like. Okay. So I'll put a little comment up here. So rank sub 0 is count of number, actually rank sub 0 is ignored. All right. Let's think about this. I'm going to just do it this way. Oh, no, get rank, it returns the true rank. So, all right, yeah. So rank 0 is ignored, rank 1 is ignored. Rank, let's say, let me look at my code for rank here. Yeah, we do add 2 to get the rank, so, okay. Rank 2 is, this is the number of 2s, cards of rank 2. Rank 3 is the number of 3s found. Okay, we're going to continue that to rank 14, and that's going to be the number of aces that we found. Okay, so that's the purpose of the rank array. All right, here, instead of having all these loops, nested inside of loops, nested inside of loops, we're going to improve this. And we're just going to do this. We're going to have the one for loop, which goes through the entire array of a hand array and simply does this. It says, let's set rank count, and we're going to index rank count by the rank of the hand that the card that we're working on right now. So I'll give you an example of what this would be. All right, so let's say hand sub I is equal to, or let's say hand sub 0 is the 2 of hearts. That's an easy one. Okay, so the value of hand sub 0 is going to be 0. All right, and get rank of hand sub 0 is going to be equal to 2. So when we have that situation, if we say rank count sub get rank of hand sub 0, we do that and we do a plus plus, then we're adding one to rank sub 2. Well, we're adding one to the number of 2s we've encountered. That's pretty much what it means. Oh, I changed this name from rank to rank count. Okay. So rank count's pretty awesome. So the plan is we're going to pass in our hand, and we're just going to change the rank count across the board. Starts out as an array of 15 integers. Rank count sub 0, which is ignored, sub 1, which is ignored, and basically rank count sub 2 to 14 are the integers that we care about. They're all set to 0, all right? Because we have 0, 2, 0, 3, 0, 4s, 0 aces, up to 0 aces. But as we encounter these cards in hand, we're going to increase rank count by 1 for each time we find a card of a particular rank. And so when we're done, how would we know if we had 3 of a kind? So if we do this, right, and we just update rank count for every time we find a card of a particular rank, how would we know if we have 3 of a kind? Well, if we go through the rank count array, if we encounter a rank count that has the value of 3, it means we called get rank hand sub I for that particular rank count 3 times. So for example, if we had 3 2s, we're going to call rank count get rank a hand sub I, which will resolve to 2. We'll do that 3 times. It means we have 3 2s in the hand array. If we had aces, if we had 3 aces, we would call rank count get rank hand sub I, where there's some value of the hand. There's 3 aces in the hand, so we're going to call get rank 4, which will return 14. We'll call that 3 times. Rank count will be incremented by 1. Rank count sub 14 will be incremented by 1 3 times. And so we'll end up with a really nice count of the rank. So, and then we can use that to scan for 3 of a kind. Okay, so rank count sub 3, or sorry, if, so if rank count sub I is equal to 3, means we found 3 cards with that particular rank. That's what this processing is going to do. It's going to record the count of the number of cards of each rank, right? And if we scan through the rank count array and we find one with the value of 3, then we're going to return true. Otherwise, if we pass through that, return false. Now, there's some complexity in what I just did here, but what's so amazing about this particular piece of code is um, I can I can reuse all of this code for a bunch of different methods. I could go back and rewrite this to use this code as well. And it ends up really, after a little bit of thought, it ends up actually really simplifying our code. Okay, so let's try is three of a kind like that and see if we can compile and run it and solve the problem. All right, we got to run it a couple times till we see if we can get a three of a kind. Not having a lot of luck with anything. This happened before. Oof, a lot of stinky runs. There we go, we at least got one pair. There's another one pair. Oof. All right, so I'll tell you what, we're not having luck. I am gonna try to get the program to run down here, and we'll just run until we get three of a kind. So what I'm gonna do is do a while true right here. Oh, we'll just make it a do while. Yeah, let's make it a do while. All right, and we'll say while hand, I'm sorry, while not is three of a kind hand. So we'll have this run until we get three of a kind. All right, and we can leave all of this here, and we're going to have to make sure that hand here, at least the declaration of hand, is out here. Now I want you to notice that I'm shuffling the deck every time the loop executes. And the reason why that's important is that the way my get hand is designed is that it just returns the top 5 cards off the deck. So if I just had this run in a loop without doing the shuffle of the deck every time, then what would happen is I would get the same cards from the top of the deck. Okay, so let's try this. Whoops, didn't need to do that. All right, so, okay, so here we go. So remember, I'm gonna run it again. So a lot of stuff appeared, but I told the program to stop when it gets three of a kind. And here we have three of a kind, a 10 of hearts, 10 of clubs, 10 of diamonds. Let's run it one more time. That was nice. 7 of hearts, 7 of spades, 7 of diamonds. Okay. So having done that, I think I can go back and retrofit this code, improve it even more. The whole process of computing the rank count, I think we should offload that into a method, because then everybody can use that. The 2 of the kind and then 1 of a kind can use it as well. Or two pair and 1 pair can use it as well. All right, so we're going to write some code right here that says compute public static compute or get rank count. And that's going to take a hand as an argument. And we're going to move this code that computes the rank count right here, right in here. All right. So what's cool about this is I get to reuse rank count in other methods. Now, I'm going to say int rank count here is equal to get rank count, and we'll pass in hand. So I've abstracted away the complexity of computing the rank count into this method, get rank count. Now, get rank count has to return something, and it's going to return the rank count array as it's been calculated. And that means that our return here is going to be an int array, an integer array. All right, so now is3of-a-kind calls getRankCount, which computes that rank count array of the count of the number of times cards of each rank appear in the hand. And then we just iterate through the rank count array to say, did we find one with 3? Because if we did, we're good. All right, let's see if we can use the same technique here for is2pair. Right, there's a lot of weirdness here in is2pair. We're double counting pairs and seeing if the pair count's equal to 4, and I just didn't get the best feeling from that. So why don't we rewrite this, okay? So this is the code from the is3of-a-kind, but let's see if we can modify it so that we can calculate is2pair. All right, so every time we find a rank count equal to 2, we don't want to return true. What we want to do instead is we want to add 1 to pair count. All right, and we'll create an int pair count right here. All right, so we're scanning through the rank count array and we're looking for opportunities where the rank count is equal to 2. So every time we find one, we're going to add 1 to the pair count. So if the pair count, if we get down here and the pair count is equal to 2, it means that we encountered 2 entries in the rank count array where we had a count of 2 or where we had a pair. And that means that we have 2 pair. So there we go. Wow, that's so much simpler and cleaner looking code than what we had before with all those nested for loops. So we can repeat this process for, or something like it, for is1pair. Actually, now that I think about it, is1pair, I bet we can reuse this code. This is even better. So a lot of code here. We're going to just replace it with, if we find that rank count is equal to true and is2pair is not true, then we're going to return true. So if the rank count, if we encounter rank count of 2 and is2pair of the hand is not true, because we only want to return it true for is1pair if we have just 1 pair, not 2 pair. Okay, so those both have to be true. Then we're going to return true. Otherwise, we'll continue through the array looking for a rank count of 2. If we get through the array and we don't find a rank count of 2, it means there's no pair in the array, and so we'll return false. All right, so that really cleaned up the code a lot. Using this rank count thing seems quite useful. All right, I think we'll stop there.